Alright guys, today we'll be going over congruence transformations, section 9.5. So this section should be not as challenging as any of the ones we've seen before. In fact, all we're actually doing is using the information we already know. So, we've already covered congruency a long time ago and obviously use it on a day-to-day basis in geometry, but now we're going to kind of go over a new way to prove congruency, right? So what we're saying in this section is that two figures are congruent if and only if there's a sequence of one or more rigid motions that maps one figure onto another. So where in the past we've proved that two objects are congruent by proving that they have all similar length sized and all similar measured angles, here we can say if we take one object, one figure, and all we do is provide rigid motion to it in some manner that we get it to be in the same location as this figure, then they're congruent, right? And by rigid motion, we mean rotations, reflections, and translations, right? The three main ones that we went over in the previous chapters. So essentially, if we can find a way to reflect ABC or translate ABC or rotate ABC so that it then sits perfectly on top of this figure, then we can say that that these two figures are congruent. Okay. So first off, just to kind of get acquainted with congruency and congruency statements, I want you guys to write out these two figures are indeed congruent to each other, but I want to make sure that you guys remember how to write out the order of congruency, right? A, B, C, D is congruent to one specific order of letters, right? So that's what question 1 is asking. All right, moving on. All right, so in the figure below, triangle JQV is congruent to triangle EWT. So what is the congruence transformation that maps triangle JQV onto triangle EWT? Okay, so we're really just jumping into it. I'll explain as we go, and it should be pretty simple. So what we're looking at here is two triangles that we are told are congruent to each other, and we want to find some sort of set of different type of some sort of transformations that we can do to get JQV to sit on top of EWT, right? So we can prove they're congruent. So here's why I made an emphasis that we remember how to write correct congruency statements, right? So we have this congruency statement here, right? JQV is congruent to EWT, which means that we can say something to the effect of point Q corresponds to point W, right? And it appears to be that way in the diagram, right? So another way that we can look at this is not just how do we plant this triangle on top of here, but we can almost just say, if we can find a transformation that puts point Q on top of point W, then you would like to think logically that we would then be able, then that would also work for the other 2 points. So let's look at that now. What would be maybe our first step at getting point Q on top of getting it on top of to the location of where point W is? Now that's not a perfect method because most of you guys might say, well, we can just literally translate it 2 units to the left and 6 units or 5 units in the positive y direction. But that obviously would not work, right? So you need to kind of keep in mind how these two images look towards each other, right? If almost anything, you can see that at some point it's almost going to seem like we're going to have to flip one of these. We're going to have to flip JQV across so that it's in the same order, right? Right now they're not facing the same way. If we put them on top of each other right now, they wouldn't look the same. So at some point we're going to have to do some sort of reflection. So the first step I would do in trying to get Q to the location of where W is I would first translate this up 5 units in the y direction. Okay, so I've just created an intermediate triangle right here. This is what it looks like when you perform this action, this transformation on the right side, right? We translated triangle JQV up 5 units, 1, 2, 3, 4, 5, in the y direction. So now we're faced with this triangle right here and this triangle right here. And we're trying to map this triangle onto this triangle right here, EWT. Okay? Now from here, hopefully it should be obvious to you that to get this point Q on top onto the position of point W and J, this point J, to match up with point E, we would need to reflect this triangle across the x-axis, the y-axis, or x equals 0. And if you did that reflection out mathematically, right, you could see that you would map it out right there. Sorry. This would go 2 units this direction and then continue 2 units. This would go 1, 2, 3, 4 units, and then so we would continue on 4 units to that point. So there you can see that if you reflected our new image right here across the y-axis, it would then map perfectly onto triangle EWT. Okay, so over here then we would write our last transformation we did, which would look like. So we have our answer right here. Okay. Also, before we get too far, I just want to say that there will always be more than one answer for these problems, right? You could have done an infinite amount of possible things. You could have first translated over here, then reflected it upon itself, and then moved it up, or whatever. But as long as you draw out all the steps that you take, except for ultimately the last one, you don't have to draw that one, and keep track of what you do, it'll be easy for me to see if what you're doing is correct, right? But again, we need to go up to the top question and see what they're asking for. They want a congruence transformation, okay? So we have our 2 steps here, but now we have to write them in a way that anyone just picking up, anyone who just looks at it would be able to follow directions, right? So what we have to do now is put these into the correct order that we learned in the previous section. So our final answer would look something like this, right here. So if you started with JQV right here and perform these actions, first we translated in the y direction and then reflected across x equals 0. This right here is our congruence transformation that would map this triangle JQV onto triangle EWT. So for this section, all of your answers will be in this format. I know that a lot of this is intuitive. The more problems you do in practice, the easier you'll be able to see what you can do to solve the problem. Okay. So now let's look at a different one. We'll do one more example of this. So again, we want to know the congruence transformation that relates the 2 congruent figures. Now this one didn't tell us, like this one before, that we were going to move JQV onto EWT. So here we can choose, you can choose which one you want to transform onto the other one. So again, we have these 2 triangles, RAV and IQS, and you can definitely tell that they're congruent. They tell you they're congruent, and you can pretty immediately see that point I corresponds to point V, and Q to R, and S to A. I think initially what someone looking at this should notice is that at some point we need to flip IQS, we need to reflect it across itself, right? So that they're both facing and have the same direction. But first, I think, well, let's actually just do that first. I would say my first step would probably be to flip it, because that's what I think needs to be done immediately. So I would first probably reflect it across, let's just reflect it across the x-axis, right, the x-axis right here, or y equals 0. So again, out here I've written out what transformation I've just done, which is reflecting IQS across the x-axis or y equals 0. And now from here it seems pretty straightforward as to how to get this triangle onto ARV. The answer would be just to transform it 1, 2, 3, 4, 5 negative units in the x-axis, and then move it up positively 1 unit in the y-axis. So, and that will get us our congruence transformation, right? So that would look something like this. So right here I have the translation written out in -5 units in the x direction. So that would be 1, 2, 3, 4, 5, and then 1 in the y direction. I plot that point there, this point there, and 1, 2, 3, 4, 5, this point there. Therefore, completing our congruence transformation. Again, you would need to change this into the correct format, which I'll put right here. Again, the only thing wrong with this is I probably should have specified that they were triangles, but so this right here would be a complete congruence transformation. We are applying these transformations to this triangle, and we are proving that it is equal to that triangle. All right. So lastly, we'll end on a question. Hopefully this should be a lot easier since we just did 2 more difficult problems. But I just want you to write out one congruence transformation that relates these 2 figures shown right there. Now I know you can't use subscripts for the answer, so what I want you to do is instead just write out your answer in full-length words, right? So if you look at here, this says reflect IQS across y equals 0, and then translate it -5 units on the x-axis and 1 unit in the y-axis, and that is equal to triangle VWR. So that's how I want you to write it out, and you're in full-length words as if you were speaking it. All right, I'm going to give you 2 seconds to pause it so that you can work it out before it's skipping.